kickstart the day, we have Anir Kargupta. If I pronounced that wrong, I apologize. Alexander Loganov from Rosenberg Fans, who will be discussing savings on space, energy, money, and reduction in CO2 emissions using the EC fan grid. Take it away, gentlemen. The stage is yours.
I'm Alex Loganov, and I am Vice President of Rosenberg Fans Canada. I have been with the Rosenberg Group for almost 25 years. And this is my colleague, Anir Kargupta. He joined the group in 2019, and he's a product manager for retrofit and special projects. And I will begin with introducing the group. It's an international group of companies founded by Mr. Karl Rosenberg, who celebrated his 79th birthday last week. And today, it was founded in 1981, and today we have 14 production sites, 45 sales offices around the world, and we have 1,400 employees worldwide. This is the map showing where we are, and it's going back. So obviously Canada, and this is where I am originally from, and in the other side of the world. Rosenberg is a vertically integrated company. All major components are produced on the factories belonging to Rosenberg. We manufacture AC and EC external rotor motors, impellers, blades, sheet metal parts, accessories, and air handling units, and many more products which are mostly sold in Europe. In North America, we offer axial fans, which are mainly cooling fans for refrigeration. We sell and offer plug fans, which are used in ventilation equipment, and wide variety of products on the OEM level. And blowers. All our fans are coming with the external rotor motors, with our own external rotor motors, which can be AC and EC configuration. And now we go to the main feature of this presentation, EC fan grid, and Anir will take over from here.
Thank you. Thank you, Alex. Can you guys hear me well? Okay. So my name is Anir Kargupta. I'm the product manager for Retrofit. And as Alex mentioned to you guys, that we have joined hands with Kilmer Environmental for Ontario as an exclusive distributor for Rosenberg Retrofit product line. So today we are going to talk and discuss more about these retrofits as to how it's installed, where it's installed, and what is the best way to save energy, reduce carbon emissions. So the question remains, if you look at the average commercial energy usage in a building, you can see from the graph, the red area, for the HVAC applications only in a commercial building, the energy usage is close to about 37%, right? So, so there's a huge impact as to if we reduce energy in that area especially, we can reduce the associated greenhouse gas emissions. That's the intention, as well as save energy, right? So when we talk about this, what we see here is the sustainability and building retrofit projects is there is higher productivity and lower employee absenteeism. Then we progress towards corporate energy saving objectives like Canadian LEED certification, things like that, as well as it improves the marketing and public relations when you have green buildings, and then reduced environmental impact by lowering the greenhouse gas emissions. So this is what we are more concerned about. So when we talk about retrofit, the question remains, what are we looking at? So we are trying to retrofit the outdated, inefficient HVAC equipment. You know, all these pictures, what you see here, as you can see, these are all big fans, single belt-driven fans, which takes a lot of space in a building. So we are trying to, change them with smaller, space-saving Rosenberg EC fan grids. So the question remains, how do we go about it, as to how we start, how we move forward with these kind of retrofit projects, and what needs to be done to achieve the optimal performance. So we are going to show you all the details in the forthcoming slides. So based on years of experience and equipped with our exclusive energy efficient and easy to control, we call it the ECM technology. Rosenberg's EC fan grid is an approach which is reliable, flexible, and very simple to operate. So we call it, as I said, EC technology. It's basically Rosenberg EC fan grid, which is a multiple fan array, and which can actually, you can use them to upgrade the existing AHUs. This is, again, equipped with our exclusive energy efficient and easy to control Rosenberg EC fan grid. We provide a complete package. The package would include the fans, the grid, the wiring cabinet, everything, right? So you're getting the complete package, so it's just a plug-and-play kind of a thing. You get it to the site, you install them, and you're ready to fly. So we have mainly three configurations. The first one, we call it as OEM AHU, which means is, these kind of fans can be directly installed by the OEMs in their own equipment. The second configuration is Retrofit Kit, where we provide the complete packaged kit, which includes, as I said, the fans, the structure, the grid, the hardware, everything. And the third configuration is the Unibox. So it's basically a box. We'll talk about these boxes in our later slides. So when we look at the existing fans, which are the belt-driven fans, how does the EC retrofit benefits over those older technology? So if you can see, the fan grid provides, it's basically very compact and flexible, easy to replace and maintain, more uniform distribution across the fan grid. It produces less low-frequency noises. Integrated speed control. It's very easy to clean. It has redundancy because there are a number of fans, so you have redundancy as well, and very less weight. Compared to what you get from the single fan is operating losses, difficult replacements. You have to change the belts. You have to use the VFDs with these, and it takes a lot of space. So when we talk about flexibility with the EC fan grid, what we see here is, these fans can actually fit. It always fits in any application. It could be any number of fans, which you can fit it for that particular area or the application. So it could be any number of fans. So we have different sizes of fans available, and you can use them as per the opening dimensions of the duct. The other point which I wanted to highlight was for the future upgrades. So if you have any future upgrades planned, you can add more fans in that grid, in the fan grid, so that you can increase the flow rate and increase the capacity of the air So that can be done as well. With a single fan, you cannot. So this is a perfect example as to what we normally have. You can see there is space on the top where you can have more fans in the future. So just put the fans there and hook it up with the system. The third thing is the compactness. Our fans, as you can see on the left-hand side, it's almost quarter the size of the single fan. The single fan, we just mentioned a number, which is 93 inches compared to 16 inches. So it's so much compact. It takes less space. That's the whole idea. So this is just a perfect example what we show here. It's a single fan. Look at the space it's taking inside the casing. And then just compare with what we use. This is the fan grid, right? So it's taking much less space. And you can utilize the space by adding more equipment, right? So this is how it looks after the installation, the retrofit installation. So you can always utilize this space for any other installation of equipment. So when you actually look at the building hallways and doorways, you have very much less space to carry these bigger fans. But for the Rosenberg EC fans, they're much smaller, compact, and it's very easy to pass these through the doorways and the hallways. This is just a graphical representation here, which shows a single fan. It cannot be taken out of the standard doorway. So you need to actually break open the door or the wall to take it out, or use cranes from the roof and take it out of the building. But in case of, all these bigger fans, they need to be torn down to be taken out of the building. But in our case, the Rosenberg EC fans, it's very simple. Just a couple of guys, they can take the fans in and out of the building. It can also fit through the narrow passages, doorways, and it's very easy to bring them in or take them out of the building. Very easy to replace. If one of the fans is not working, just a couple of guys can actually come in. They can replace the fan. It's boom. It's again back to, back in action. When we talk about the air distribution, you can look at the slide and see with a single belt-driven fan, you have high spot air velocities and uneven airflow. So what happens is, you have the wheel, which actually creates a lot of barrier. In fact, it creates a heat recovery wheel, which creates bad flow, as well as creates pressure drop across the duct. So what we did was we took out this panel and created a complete open space in that ducting, which actually made the flow better, and we had pressure gain. So it has completely even airflow, less spot air velocity, and more uniform airflow. Sound. With the EC fan grid, they are having high frequency sound compared to the single belt-driven fan, which are less low frequency fans. So for the EC fan grid, you need a smaller attenuator compared to a bigger attenuator for the single belt-driven fan. Easy to clean because you have restricted area in the single belt-driven fan. It's not very easily accessible. The floor is not easily accessible, so it's very hard to clean the floor with a single belt-driven fan. But with the EC fans, the floor is accessible, so it's very easy to clean. So this is an example of how it looks like at the installation site for a single belt-driven fan. Look how dirty the floor is, and the other areas as well. So it's very difficult for a person to go in or something like that to clean the inside area. So this is the actual area which looks very dirty, because of the different, lubricants, whatever, the belt, all that create a lot of, dirt inside. In terms of EC fan grid, the floor is completely accessible. It's very easy to clean. This is the area where you see is very clean. So what we provide in a retrofit kit, we actually have, they have these retrofit kits which fits most of the AHUs. It doesn't really matter who the manufacturer is. It fits every single AHU. We provide complete kit. The kit includes the mechanical parts, which is the fans, the fillers, the mounting plates, the hardware, the wiring cabinet, and other accessories too. We also provide the installation guides and the wiring diagrams. And again, it's mobile, so you don't have to actually have cranes and things like that. It can just fit through standard doors and openings in a building, and it can be easily taken inside. So this is a graphical video of how the EC fan grid is installed. So while the video is on, I will keep on talking as to what is happening within these installation. So this is the casing. This is the top rail, which goes in with the hardware. Then comes the side rail, which gets fitted into the casing with the hardware. Then you have the first nozzle plate, which goes in, the cone plate, to the rails, the side rails. And then there are a couple of intermediate rails, which gets hooked up to the casing. Second one coming in. Now you have the second set of the cone plates, which gets fitted with the hardware. Then you have the last one, the last rail, which gets fitted to the casing again. And then from the back, you can see the fillers, which goes on the top and on the side. So all these are the hardware. Now is the cone plate, which goes inside the actual cone. Then you're hooking up with the tubing. The fans come in. All the 4 fans together. This is the wiring cabinet, which get hooked up to the system. So this is how we actually install the retrofit, the fan grid inside any AHU. Very simple. Again, we have another video. It's a time-lapse video on EC fan grid retrofit installation. This video shows the actual installation by a couple of guys who have changed the single belt-driven fan to a Rosenberg EC fan grid. that was the quick time-lapse video for the EC fan grid installation. Now we are in the Unibox section where this is the third configuration I was talking about in my previous slides. This is a Unibox, is an assembly consisting of a backward inclined impeller and an EC fan, again with the ECM technology, inside the enclosure. The box is made of extruded aluminum frame. Again, this is a galvanized steel panels powered with our energy efficient and easy to control EC motors. It's very simple plug and play kind of a thing. So you can actually use these Uniboxes for any installation. You can just stack the boxes together to the opening and it's a plug and play kind of a thing. The other feature what we have is you can actually connect these fans with the building BMS system, which is the BACnet. So we can provide a gateway as well, which will communicate. We have the Modbus interface. So it will communicate with Modbus interface and convert the signals to the BACnet. So we can provide that as well. Now, talking about different applications, the fan grid can go to different applications. It can be used in data centers, school buildings, HVAC systems in buildings, hotels, hospitals, warehouses, pharmaceuticals. You just name it, and you can find applications for Rosenberg EC fan grid. This is just a picture to show you, we have been using these kind of EC technology for cooling towers as well as for air-cooled condensers. So the same technology, ECM technology can be used for doing retrofit as well, which can save a lot of energy. Along with that, we have a beautiful fan selection software. We call it Rowan software. You can actually download this software from our website. So what it does is it can do the selection for you as per your application. You will just input your information, your opening dimensions, the flow rate in CFM or liters per second or whatever, different measurement units. And what it'll do is you can actually look at the graph on the right-hand side. It will give you the graphical values as to you can do the selection based on your application. It will give you the selection based on whether you need it to reduce the sound or you need more efficiency. So based on those parameters, you can do the selection of these EC fan grids. And it will also give you the dimensions as to what dimensions you are getting from that selection. This software can also get you a life cycle cost analysis. So you can actually input your data for the existing fan what you selected and the existing fan what you have at the site. So based on these two different data, it can actually tell you the ROI. So for example, in this, the ROI is less than half a year, 0.4, right? And the CO2 emissions is close to about 10.1 tons, which is, there's a reduction in CO2 emissions. At the same time, the cost savings is close to about $14,000 a year. That's the energy savings, just the energy savings. So we have a beautiful website. It's called the ecfangrid.ca. So do visit that website to download that Rowan software. We have showcases in that website to give you the stories of how we did the changeover from single belt-driven fans to Rosenberg AC fan grid. Different examples, different energy savings examples are there. So it's very informative. So do visit our website to have more information. So now we come to the retrofit installation case studies, which Alex is going to go through.
Yes, thank you, Anir. Yeah, we have many showcases on our website, but here we would like to show you just a couple. One was done back in 2013 in one of the Bell buildings in Hamilton, and another retrofit was just recent retrofit in Toronto, done on Bay Street in Toronto. In both cases, the reasoning and the motivation to go with the fan grid was similar. So basically, it's to avoid the very expensive construction by removing and installing the same fan, and also save on running costs after the installation. So in Hamilton, the fan was still operational, but it was running out of time, like at the end of the life, and that's when we started to work on this project. Because of the compactness and lightweight, our fans were quite easy to handle and bring them inside the building, inside the technical room, with all this equipment. The fan grid was installed. Where's the? Oops, no. Sorry. So the fan grid was installed in this box, while the old fan was still in place and running. And it was disconnected and demolished after our fan grid was commissioned and fully operational. We used the Uniboxes in this case. There was 6 Uniboxes, 6 fans running and 1 standby. And it's due to the customer requirement to have N+1 redundancy level. We also did the energy analysis, and it shows the 40% savings compared to the old fan, which converts to approximately $10,000 a year of savings based on 12 cents per kilowatt energy cost. The second project was done actually with the Ambient Mechanical. And again, the motivation was the same. The customer wanted to save on capital expenses by replacing the fan. On the fan replacement, the fan was kind of dead, and there wasn't a problem. So, and here is what was built instead. It was a 9-fan fan grid, constructed in 3x3 configuration. I heard that the customer requested the energy savings analysis from the professional firm, and the analysis showed that the savings were close to $25,000 a year. This is it from us. If you have any questions, we would be glad to answer.
Humidifiers in, or put humidifiers in, or a filter bank, or something like that. So that's a secondary benefit of freeing up all that room.
So that wasn't the question. There was a comment, right? Yeah. Thank you. Yeah, there are a lot of benefits of installing the fan grid, and well, saving on the construction or replacing the fan is not the only one. Yeah, you actually getting the benefits more after the installation by saving on energy costs. All fans come with the EC motors, and you know the EC motors can really be a game changer in terms of the saving energy. So. Yes, Paul? They sit all in front of us. Yeah, we don't do the installation ourselves. It's we're providing the equipment, we're providing the kit and the instructions, supervision, and and we can participate in commissioning, but no, the real work is done by the contractors. Thank you very much.